Thanks. It's really good to be here. What I want to do is I want to talk about diversity, probably in a way you typically don't think about diversity. So last night when I got in, some people recognized me, I think, because my picture's up all over the place. And they're asking me, what it is that I do. And so it's interesting. I'm not a typical diversity speaker or person. So my work is in this area of complex systems. So my PhD is from Northwestern, and it's from the business school, and it's in game theory. And then I moved to Caltech, where I sort of switched my research again and started studying things related to complex systems. So things like the brain, traffic, economies, political systems, international relations, middle school, right? Things like that. And my most recent work has been on things like, how do you introduce goods in sort of the new weightless economy? How do things like culture form? So it's really I'm sort of an interdisciplinary modeler by training. So I moved in this diversity space for the following reason, is that this is a very ideologically loaded space, and it's also very normatively loaded, right? And I was working with a group of scientists, probably somewhere between 50 and 100 of us, who were just trying to understand functionally what roles does diversity play. Does it make things better? So when people make the argument for why do we want more diversity, typically we make some sort of social justice argument, right? So what we might do is we might look at, this is a gender graph for different specialties. I realize you can't read it, but you can see that most of them are sort of very highly male dominated. But this is kind of unfair because it's also showing a system that's kind of moving through a pipeline. But even if you look at sort of those doctors entering practice in 2015, you still see substantial sort of gender bias. If you look at like racial bias by region, again, you see these big differences. And when we say, okay, so from a social justice perspective, we'd like our professions to be more equal, there's also an argument just based on demographics, right? That American society is becoming more diverse, and so therefore it's important to have our professions represent and reflect the societies we're in. Those narratives are out there, and there are people that are experts in those areas, but I'm not your guy in that area. And the reason why is it's just not something that I study, right? I'm trained as a mathematician. So what I focus on is trying to think about how is it that diversity, differences in how we think, lead to better outcomes. And I'm going to give, I'm trained as an economist, so my sons like to joke, if you ask me any question, my answer will be, it depends, right? And so the answer here will be, it depends as well. But what I want to get at is this following sort of idea, is that most people, when they think about diversity, we think about identity diversity, and we think that there's some sort of trade-off. So the University of Michigan had this famous court case, the Grutter case, where Justice Scalia said, Michigan has a choice, right? You can be excellent, or you can be diverse. Actually, he didn't use the word excellent, he used a legal term, super duper. He said you can be super duper, or you can be diverse. But I want to argue that this isn't right? That when the task that we're on is complex, when it's hard, that diversity actually is sort of instrumental for excellence. Okay, so this most recent book, The Diversity Bonus, begins with this quote by Wendell Berry, who talks about living by the contrary assumption, right? That what is good for the world could be good for us. And that's really the central theme of this book and also of this talk, is that we think about being more inclusive as being sort of good for the world, the right thing to do. But we don't necessarily think about it being good for us, allowing us to be sort of better doctors, better citizens, right? Create better universities, better hospitals, that sort of stuff, right? We think there's a trade-off. And I actually want to advance the contrary assumption that those things are actually lined up. But because I'm an economist, because I'm a mathematician, by training, everything's sort of conditional. So that's not always going to be true. So I want to start by talking about where it's not true. So this is a northern Michigan logging camp. And when they would hire people at these logging camps, what they would do is they would count how many trees somebody could chop down. So this big dude can chop down 12. The smaller guy who's also smoking a pipe, you can't quite see the pipe maybe, he can only do 8, right? And if I were to add up how many this team can do as a whole, it's 50. Now to be fair, they didn't just see how many trees you could chop down. They also counted your teeth, because you needed to sort of be able to eat enough meat to have protein the next day, right? And so my son was taking the SAT scores this morning, so it's like verbal plus quantitative. At these logging camps, it was trees plus teeth. That was your score. The higher you scored, the more likely you got hired. But this is an additive world, and in that world, you want to hire the people with the most trees and teeth. And where diversity enters there is in the sort of non-discriminatory sense, right? If there was a woman who showed up who had a lot of teeth and could chop down a lot of trees, you should hire her irrespective of gender, right? But there's no sort of benefit directly from diversity. You can measure everything by ability, and any argument for diversity is really one about discrimination. This is a map that purposefully you can't see. I was involved in this project with the Foresight group, trying to figure out what the causes of obesity are, and we solved it. There it is. in a simple graph. If you dig down deeper, you see all those little boxes that are different colors. Some go with media, some are social, some are psychological, some are genetic, some are infrastructure. So everything from giant Cokes to genes are in this graph. And the point is, if you wanted to hire a team of people to understand diversity, you can't like count trees plus teeth, right? What you need is you need diverse people with different specialties and different understandings and different knowledge in order to understand a problem this complex. So what I want to do is I want to kind of, starting from those two metaphors, that somehow chopping down trees is simple and solving obesity is complex, that on the simple problems we don't need diversity, on hard problems we do need diversity. I want to sort of try and unpack that the way a scientist would unpack that. So the way a scientist would unpack that is we'd say, okay, let's have a theory, let's write down a model, then let's test the model, right? So what I want to do is I want to sort of try and play through a logic that sort of says, when is it the case? So people throw this word around a lot. This is Astro Teller saying diverse perspectives are really a great thing. We need people from diverse perspectives. I want to formalize that in some way so that I can show that, like, when is it the case that diverse perspectives are better, and what do they make us better at? To get there, the first thing I've got to do is I've got to, like, get rid of the wrong metaphor, okay? So here's the wrong metaphor. People will say, we need diverse people for the same reason we need a diverse portfolio of assets. Okay, so I spent a huge chunk of time this summer with BlackRock, which I kind of know who BlackRock was. Then when I got there, I realized they manage $6 trillion in assets, which is a lot of money, like more money than everybody but like China and the US have. They're third. And they were using this portfolio analogy, and I spent the whole time saying, no, this is not the right analogy, because let's think through the analogy. The analogy says, suppose I invest in the airlines, and that's the yellow thing, and the oil companies. And suppose oil's doing badly, and since oil prices are low, airlines are doing well. If the airlines are paying 12% and the oil companies are paying 2%, I'm going to get on average 7%. I get the average, right? And so the reason why we have a diverse portfolio of stocks is to spread risk. That's the logic, okay? When we think about what we do in the modern economy, we don't spread risk. We do things like predict, we solve problems, we design, we take actions, we evaluate, we verify, we engineer things. Each of these processes of which people do, we have models for, we have science about, and if you unpack it, you can show that there's benefits from diversity, but the benefits from diversity are not averaging benefits. The benefits from diversity actually give you bonuses, okay? So the reason I wrote this book called The Diversity Bonus is because there are mathematical and empirical bonuses. If it were averaging, this book would have been called The Diversity Average, and then it wouldn't have sold at all, right? No book with the word average in the title does very well. I want to start with a different book, though. This is a book by a friend of mine, Jim Serwicki, called The Wisdom of Crowds. And Jim begins this book with a story of the 1906 West of England Fat Stock and Poultry Exhibition. And at this exhibition, 787 people guessed the weight of a steer. Now, quick aside, I teach at the University of Michigan. People often ask, is it Michigan or Michigan State which has the agricultural school? Well, someone from Michigan made this graph of a steer for me. You can tell which school does not have the agricultural school. Okay, so just label that, let it go. Okay, so the average guess here is 1,197 pounds. The actual steer weighed 1,198 pounds. So the people are within a pound. Now this is where we kind of have to become scientists as opposed to just sort of like casual empiricists. So what we have here is we have this great example of the crowd got things right. But what we'd like to know is, what are the conditions when the crowd gets things right? What has to be true for this sort of phenomenon to occur? Because we also know cases where crowds get things horribly wrong. We just have to think back to 2008, right? Where all of us lost like 45% of our money because the crowd got housing prices completely wrong. So you can write a theorem, and a theorem that looks kind of like this. It says the crowd's error equals the average error minus the diversity. Now this is a theorem in the sort of like, you know, high school algebra sort of sense, that it's a mathematical identity. So the C there at the end is the crowd's prediction, so the average of the prediction, and that theta is just the Greek T, so that's the truth. So the thing on the far left there is just how far off is the crowd from the truth. What you think might be true would be the crowd is kind of as good as the people in the crowd are on average, and that's the second term. 1 over n is just divided by the number of people, and then we're just summing up how far off each person was. Well, if you do the math, you say, okay, the crowd error should equal the average error of the people in it, you find that that's not true. You find the crowd is actually better than the people in it. And the amount by which the crowd is better than the people in it is the diversity, the difference in the predictions. Now this is a lot of algebra, so let me explain the logic. So suppose Rebecca and I each have this amazing ability to always guess the weight of a steer within 6 pounds, and we're always off by exactly 6 pounds. If she's 6 too high and I'm 6 too high, then as a crowd, we're both 6 too high. And if she's 6 too low and I'm 6 too low, then as a crowd, we're both 6 too low. But if she's 6 too high and I'm 6 too low, our errors cancel out. Our different ways of seeing the world cancel out, and we get it exactly right. So what happens in prediction, the reason there's a bonus, is if people have different models, if people look at different variables, if people see the world different ways, to quote Aristotle, if they have different perspectives on the world, then what happens is they make different predictions, and in those different predictions, the errors, if they go in opposite directions, end up making the crowd smarter, okay? So 10 years ago, I wrote a book called The Difference, where I said, hey, here's this cool equation. I wonder how, we know this is true, by the way, right? This has to be true. It's like, it's a mathematical identity. But the question is, how big is the effect? Well, if you go to the Galton steer data, 1197 pounds, remember these are squared errors. The crowd is off by 1.4, so if you square it, it's 2. The average person was off by about 70 pounds. So the key takeaway here is these were not, I like to joke, these were not like cattle weight guessing savants. These were not people in the west of England who could look at a steer and know the steer within a half a pound. They were no better than you or I were. They happened to be diverse. Why were they diverse? Well, there's an obvious explanation. They'd just taken their own steers to market. They just weighed their own steer. This one was a little bit bigger than mine, a little bit smaller than yours. We probably just anchored and adjusted our way to different predictions, and we end up getting it right. Now, the interesting thing, this is not going to let me go back, is with a portfolio of assets, we get the mean. With a group of people, we get better than the mean, right? You can say, okay, does this play out, though, in other cases? So Google, I've done a lot of work with Google's work team, and what's interesting is they get 3.5 million applicants, right? I have good friends who are admissions directors, right? And I'm like, 50,000 applicants, whatever, right? 3.5 million. If you got 3.5 million, you can do a lot of experiments and run lots of data. So if they just randomly picked someone, that person would be no more likely than average, 50%, that's on the far left, than being a better than average Google employee. If one person interviews that person, they do 74% better. If two people, 81% better. What they find is that if they have more and more people look at that potential employee, they do better and better and better. That's the diversity prediction theorem. But what's interesting here is the magnitude of the effect. It drops off at about 5, right? They stop interviewing at 4. And so what this is telling us is it's kind of a proxy for how complex is the problem. So what you want to take away from this is that, like, when do you need diversity? You need diversity when something's hard. Figuring out who to hire is reasonably hard. What about figuring out the economy? The economy should be harder than, more complex than a person. So here's an amazing data set, and I wouldn't have dared make this up. So when I wrote the previous book where I put that equation in it, I said, it's just going to depend on the case how big that bump is. So this is some work by Jack Soule at Duke, where they looked at 28,000 forecasts by professional economists. So in the European Union, there's 43 economists every quarter who predict the 6 main indicators, like unemployment, inflation, growth, that sort of stuff, right? So these are all the big boys and girls, and they're making these predictions. The crowd is 21% better than the average economist. These are all top-flight PhD economists. The crowd is 21% better than the average one. I wouldn't have dared made it up. Now, here's what's really, though, intriguing about this. Look at the red dot up there. That's benchmarked at 1. If you take a random economist, their error is 1. If you take 2 economists and you just follow that curve down, you get 8% better. And if you take 3 economists, you do 12% better. But what's more interesting than that is the purple line. The purple line is the best economist to date. So in the American data, the best economist to date in most of this data is Abby Cohen from Goldman Sachs. She's 10% better than an average economist. Here's what's really counterintuitive, and you want to kind of hold in your hand and take away. If we average Abby with the second best economist, who by definition is not as good as Abby, right, we get 17% better, right? She's 10% better, the next person's 9.5% better. When we average them, we get 17% better. Why? Because when we're predicting, there's a bonus, there's not an averaging. If this were true in your stock portfolio, it'd be awesome. If one stock got 8%, the other stock got 6%, if your portfolio then got 15%, that would be great, right? But it doesn't work that way. So this is why the portfolio analogy is a dangerous analogy, because however diverse you want your portfolio to be, you actually want your predicting to be more diverse, right? Because of the fact you're not getting an averaging, you're getting this huge bonus. Let me take this to science and then the movies, then we'll move on. So this is Gonzalo Araqueses, who's a everybody promise you're not going to hire this guy away, but he's our most cited person at the University of Michigan. He has like 160,000 citations on Google Scholar, right? Unbelievably prolific scientist. And he's part of a research team that does gene identification. So this funding agency decided to have a competition between Michigan, Harvard, and MIT. And so it's the Sanger Institute at Harvard, the UMich, which is Gonzalo's group, and then the Eli Broad Institute at MIT. And what you're seeing here is graphs of the error rates. Now, as we like to say in Ann Arbor, if you're going to have Michigan, Harvard, and MIT compete, Michigan's going to win. And that's true. Michigan wins. And MIT is going to take third. And that's also true, right? So you can see MIT's in last place. Harvard in the red line is a little bit worse than Gonzalo's lab, which is in the light blue line. But what's interesting here is the funding agency then said, okay, here's what we're going to do. Now that we've got all three of these models, we're going to have them vote on whether something's a gene, right? That's the dark blue line. So who's best? Not him. Who's best is the three of them voting. Why? Because by having other models come in that aren't as good as his model and averaging them in, you actually do better, okay? So let's unpack this in something that's not very important, which is movies. So in 2006, Reed Hastings, who's the CEO of Netflix, decided to do this really funky thing. He said, we have this thing called Cinematch, which when you rent a movie, it tells you how much you like the movie. So if I rent Rush Hour 3, if I click on it, it's going to say 1 star. Actually, if any sentient being types in Rush Hour 3, 1 star, because this movie sucks. It's a bad movie, okay? If you type in Avatar, it's tricky. I have 2 teenage sons, so it's going to predict 5. But somebody else who maybe watches, like, French intellectual films, it may say 2. Like, blue people running around a forest, this isn't going to be that interesting for you, right? So it's a challenge to figure out, this isn't rating how good is the movie, it's rating how's the movie going to be for you. So here's what they did. 6 years of data, 500,000 users, 18,000 movies, they just threw it all out there. Said, everybody play with this, see if you can predict which movies people like. As soon as they did this, the Supreme Court said, you cannot do this. So this may end up being the largest data set ever publicly released. It was at the time, and it still is, because this was just considered too much information to just throw out to the general public. The idea was if somebody could beat their internal algorithm by 10%, they would give you $1 million. Now, here's where diversity comes in, and here's where this gets super interesting. So here's the idea. What you do is you got to take each one of these movies and turn it into a set of attributes, characteristics of the movie. And then you have to turn each person into kind of weights on those attributes. Like, do they like those things? So what are attributes? So things like, how much did it make in the box office? How many weeks in the theater? Is it action, drama, comedy? What are the critical reviews? One of the things is Morgan Freeman in the movie, right? That actually matters. She's the only person not in any bad movies. And somebody's like, what about Meryl Streep? I'm like, you've seen the Kevin Bacon, Meryl Streep River movie. And like, right, okay, put it aside. Right? So what you can do is take every single one of those 18,000 movies and write down everything you know. But there's a catch. That's going to take a lot of time. So you can only write down things that you can kind of scrape off the web. So you can scrape off the web that Morgan Freeman was in the movie. You can't scrape off the web that there was like a lame music video 2/3 of the way through or something, right? So this becomes this interesting challenge of trying to scrape as many attributes as you can that are going to allow you to predict. So who wins? So the star of this is Dr. Robert Bell. He's at AT&T Research Park, but they called their team Bell Core because it's the old Bell Labs. And they had 50 dimensions, which is pretty remarkable, right? So this is his team. This is really kind of diversity in action. They were able to think of 50 different dimensions for each movie that they could scrape off the web. And their best model was 6.8% better after the first year, but they had 107 different models. When they combined their 106 not so good models with their best model, they got to 8.4%. Right? And again, this is just sort of the diversity prediction thing playing out. Well, here's what's kind of fun. But Dr. Bell's boss comes into him and he says, after, it's almost 2 years now, and he says, it's really great that you're winning this thing, but you have this thing that we call here a job, and we would like you to go back to your job. Because, like, let's be honest, $1 million at AT&T Research Park is not very important, right? This is like their chief data scientist, and he's wasting his time figuring out who's watching movies. They're like, you should probably go back to work. So Dr. Bell says, okay, fine, I'm going to just win this thing then. And his boss is completely confused because he's like, look, you haven't got to 10% in 2 years. How are you going to do it now? And he says, easy, I'll just call someone not as smart as me. Because he can't go down, there's no one down the hall smarter. He's the smartest, his team is the smartest. So what he can do is he can bring in people who are different. So they bring in these Austrians who are really good at figuring out how you put different weights on the models. There's a whole art to doing these things called Kalman filters and stuff. You put different weights on models. So they're experts at that. And then they bring in these Canadians who have these really interesting behavioral insights that no one else had thought of. The most impressive one is the last one, which is delay. And this is sometimes called the Will Ferrell or the snakes on the plane breakthrough. And here's the idea. The Canadians figured out that any Will Ferrell movie and the movie Snakes on a Plane, there's a category of movies that are kind of the cinematic equivalent of margaritas. What I mean by that is, right after you've watched the movie, just like right after you've had that second margarita, it seems fantastic. The longer you wait, the less fantastic it seems. So people who rate Snakes on a Plane right after seeing it tend to give it 5 stars. People who wait a month and have actually had reasons settle back into their brain give it 1 star. Okay? So now, this is the point where, like, in reading accounts of this and talking to Dr. Bell about this and talking to people about this, what's amazing is now they have 800 variables per movie. That's just mind-numbing, right? I mean, how can you sit down and think of 800 different things that you can scrape from the web for 18,000 movies? 800 variables. Their best model is at 8.4%, which is a bonus from all these different variables. And when they combine their models, they get to 10% and they win, right? So here's the third bonus. But here's the catch. Here's where it gets really fun. The contest says once you get to 10%, the contest will then end in 30 days. The reason that Reed Hastings did this is they were afraid of people at the big public universities, because at big public universities, undergraduates have access to these giant supercomputing clusters. They were afraid some undergrad would download the data and beat them by 10% in the first 5 minutes. And that would have been like a really, it would have been a nice sort of transfer of funds from, San Fernando Valley to, or from the Valley to Champaign-Urbana or something, but it wouldn't have been an interesting contest. So now Dr. Bell realizes he's got to wait 30 days. His reaction is abject fear. And the reason his reaction is abject fear is there's 23 teams from 30 countries, and he knows 2 things about those teams. He knows he's smarter, right? He's got 2 years of data showing he's smarter, but he also knows they're more diverse. And with 2 days to go, they take the lead. They beat him. They send in their final things, and it's a tie. Actually, Belcour beats him on the 5th decimal point, but the contest rules goes to 4 decimal points. And as I like to say, in the only time in human history graduate students have been punished for checking their work, the graduate students who are combining all these other models checked their model one last time, and they submitted 22 minutes later and lost, because that was the tiebreaker. Okay, so you have so Belcour wins it, even though they tied. But the beauty of this is that the ensemble has graduate students on it, which is, so they're snarky. And on their webpage, they basically say, it's official, Belcour takes second. This is all it says. It says, here's the final results, it's official, Belcour takes second, which is completely confusing to everyone except for those who are kind of in on the joke. And the joke is, I have 2 models. They have the same error. They're different. What has to be better than either model? The average. Has to be better. Has to be better, right? So I teach this online course about using models to improve your thinking, and I think next month I'll get over like my millionth student in this course, right, which is kind of daunting. But in that course, I have this theorem up there, right, the diversity prediction theorem. On a fairly regular basis, I get emails from people, and they either say, dear Professor Page, or if it's an undergrad, it says, hey, right, in the thing. And then it says, I hope you're sitting down, but you're not going to believe this. I took data from this thing that we had in our firm, or this jelly bean contest, and I plugged it into that equation, and the equation works. So I have this slide that I've already kind of got made up that has a triangle on it, a right triangle, where one side is 5, one side is 12, and then the hypotenuse is 13. And I say, hope you're sitting down. Check this out. 5 squared plus 12 squared equals 13 squared. The Pythagorean theorem works again, right? The point about the diversity bonus is that it's a mathematical fact. It's always going to be the case, right, that the crowd error equals the average error minus the diversity. The challenge, the management challenge, the team composition challenge is how do you get diverse sets of models in the room or thinkers in the room that on average are pretty good, that collectively are diverse? Because if you can do that, you get a big bonus. And it was amazing, and this is why like that economics data really kind of was overwhelming to me because like there was a lot of data on things like jelly bean contests and stuff like that, like just kind of fun things that I'd put together and other students had put together on things like the NBA draft and things like that. And I was getting bonuses of 4, 5, 10%. But those weren't among experts. I expected when you got to experts, the bonuses would be smaller. But it turns out when you have experts, you're looking at more complex problems, right? And it turns out the bonuses are bigger. Okay, so let's think about how does that matter for the people in this room? Well, it matters for the people in this room because the thing is what Netflix learned from this is that this wasn't about finding the best person. This was about getting diverse ideas in the room, not in a touchy-feely, unquantifiable way, but in a kind of measurable bonus, measurable bonus, measurable bonus. So let's look at a liver transplant decision, right? So I was, looking through liver transplant decision-making websites the other day, right? Just for fun. And I noticed that like a lot of different hospitals have teams that consist of all sorts of different people, right? This is, with different specialties. This is exactly what you want to do, right? You want people, if you're deciding between patient A and patient B, and you're giving those people a score, you want all these people who are framing, this is a high-dimensional decision, you want people with expertise along all these different dimensions. And we'll come back to this in a few minutes. Okay, so that's prediction. Let me very quickly do solving problems. This is kind of how I got into this whole space. I was teaching undergraduate economics at Caltech, and I was writing down models of people solving problems, and one of the things I found was the following, is if you have a difficult problem and you create a bunch of problem solvers that like represent the problem in some way, and then have some heuristics or algorithms or tools to solve it, and you put together moderately large teams, then what happens is the very best team will be diverse, but if you take a team of the best people, the best individual scores, they'll actually do worse than a random team. So if you have a threshold for kind of like, do you know what's going on, a random team of people who know what's going on actually do better than a team of the best, but the very best team will be a diverse team. So this paper was out there for like, 10, 15 years, and some people were critical of it, other people were saying like there's got to be sort of a more general result. And there's two more general results. I'll show you one of them here. This is by John Kleinberg and Maithra Raghu. John, some of you may know, is a Genius Award winner from computer scientist at Cornell. They said, what if we thought of problem solving instead of people like having tools that they solve problems with, we thought of people like sort of just dumping their solutions on a table and everybody kind of like doing something with all those solutions. What they find, which is fascinating, is if you do something other than chop wood, so if it's a non-linear function of the things people throw on the table, so you're not just adding up 10 plus 12 plus 8, then not only does it turn out that the best team doesn't consist of the best individuals, they show that there's no test that you can apply to individuals such that the best team consists of the people who score highest on that test. So what does that mean? That means if you've got 50 applicants for a residency, there's no test you could apply to those people such that the 5 people who score highest give you the best team. The reason why is you're not picking individuals, you're picking a team, and you need people who are diverse. So what's really intriguing here is that if you just kind of sit back and separate out all the social justice stuff, all the demographic stuff, and you just sort of say, what we want to do is put together really good teams for predicting or solving problems, what the math says is you want diversity. And it also says you can't have a test where the best to pick individual people if you're comprising a team. Now, if you're chopping wood, you can, but you can't if you're doing something hard. So again, you get this kind of weird result. Last one here is finding creative solutions. And here I'm just going to give an example that I did with the Federal Reserve Bank in New York. We were sitting around talking about like uses for blockchain. So I said, hey, let's do the alternative uses test, right, which is otherwise known as the brick test. We say, what are the possible uses for a brick? I said, what are the uses for blockchain? So here's 3 people, Arun, Betty, and Carlos, and these are the sort of things they thought about. One of them said data, all of them said hospital, all of them said legal, regulatory stuff, art, scientific stuff. And the way you score people's creativity is by how many ideas they had. So Betty has 7, Arun has 6, and Carlos has 6. But the thing is, the group only has 9. So if you just sort of said, how creative are people, you'd say, well, Betty's the most creative. But the interesting thing here is you can figure out, there's something called Shapley Value, which does the following. If everybody has the idea, you give that idea a score of 1/3 for each person. If 2 people have it, you give it 1/2. And if you're the only person with the idea, like Arun for art and scientific uses, you give them a score of 1. Now you suddenly see that like Arun actually is the most creative, right? Betty's in the middle and Carlos is least creative. So the thing is, the same is true if you're putting together a creative team. It's not how creative you are individually, it's how creative you are relative to the other people in the group. And that's going to mean, can you think of different stuff? So the author Stephen Johnson, who writes about innovation, calls this the adjacent possible. If I give you an idea, what are the sort of adjacent possible things you think of? Different people think of different adjacent possibles, and what really determines group creativity is having people who think of different things. Again, same story, different verse, right? Portfolio of assets, you get the mean. If you're doing something creative, you do better than the best. So if you looked at academic research, this is kind of a classic case of creativity plus problem solving, right? You throw out ideas, and then you solve those problems. So again, now we can go to data. So when I wrote my previous book, The Difference, 10 years ago, there really wasn't a lot of data. Now there's been a ton of data. So the National Institute of Health a few years ago had a huge research project on the science of team science. And these are sort of the 4 main bullet points. Teams are more innovative. There's an inverted U with respect to diversity. So if you have a dial for cognitive diversity on a team, if you have none, you do really badly, and if you have too much, you do really badly, because you can't communicate with one another. So there's a sweet spot in the middle. So the point is not to come out of this talk saying, let's turn that diversity dial to 12 or 11, right? You want to have it somewhere in the middle. It turns out, again, within the National Institute of Health, women tend to be more collaborative, and that as the task becomes more complex, as it's higher dimensional, you have to have devices, oftentimes like physical artifacts, that improve coordination. Okay, I find it sometimes hard to read these NRC reports and NIH reports because there's just tons of bullet points. So let me dig down a little bit more. If you look at this thing, this report, and this is some papers by Brian Uzi that were contained in it. In 1960, this is the number of authors on the bottom. Most papers had either 1 or 2 authors. If you look in 2016, most papers have more than 5 authors, right? Why is that? A good benchmark for an influential paper is getting more than 100 citations. The odds of getting 100 citations are 4.5 times as high in a co-authored paper as a single-authored paper. Now you could say, how big's the data set here? And I would respond, 24 million papers. It's every paper ever published. So this is the really funky thing about how the world has changed in the last decade. So a decade ago, people might do a study where they randomly selected 300 papers. Now they scrape every single paper off the Web of Science, and they can say, this is just a fact. So this isn't a finding, this is a flat-out, on-the-ground fact. Now, why is it? It turns out, if you unpack why is it that co-authored papers do better, it's not having more authors. It's having authors who think differently. So if you do here's one really just sort of incredibly crazy result due to Melissa Schilling, hold everything else constant, and change the university of one of the authors from the same university as another author to a different university. So instead of working with someone from the University of Chicago, go to Ohio State and work with someone from Ohio State, but hold everything else constant. You're 7% more likely in the sciences and 12% more likely in the social sciences to reach that 100 citation barrier. This I'm just going to show graphically. If you take a co-authored paper versus a non-co-authored paper, you get a little bonus, which is that yellow box. Okay, so that's kind of having the more authors bonus. If you have more citations on your previous work, you get a bonus equal to that blue box. If you have, and this slide says atypical combinations, if you cite research together that hasn't been cited together in the past, so the sort of canonical example here is Danny Kahneman, who won a Nobel Prize in economics, cited papers in psychology and papers in economics, right? So he's combining, it's an atypical combination. If you make an atypical combination, you get the red box. So if you co-author, you get the yellow box. If you co-author with smart people, you get the blue box. So that's the ability box. If they're combining different ideas, you get the red box. So this is saying no trade-off, right? Ability's good, diversity's good. The big green box is if you have both the blue box and the red box. So if you have high-quality people and you're combining atypical things, you get a third bonus bigger than either of the independent bonus. So this is the interaction term if you run regressions. The interaction term is larger than the linear terms. So what this says is, what you really want to do is work with smart people who think differently than you are, right? That's a fairly obvious point, right? And this is what my younger son always says. If somebody says, where's your dad? They said, he's out talking to some really smart people and saying something very obvious, right? But what's incredible about this isn't the very obvious thing, it's the magnitude, right? The very, very best papers, right? The most impact, and the same holds for patents. The most impactful patents, the most impactful papers are being written by very accomplished people with diverse sets of skills, understandings, and tools. So same thing's true with patents. It used to be that over half of patents came from 166,000 patent classifications. It used to be most of them came from one. Now, actually, last year it was less than 10% came from one of these categories. So you can think of innovations as either being leaps, where someone has a whole new idea, or kind of creeps, where you're combining things. Most patents are now combining things, which means diversity. Okay, so how does this relate to identity diversity, right? So this has all been cognitive. So let me just quickly talk identity and then talk very quickly about some actions, and then we'll wrap this up. So how does identity diversity come in? Again, you've got data, you've got a lot of data, and the data here is messier, and it's harder to kind of make sense of. And this is some work by Catherine Phillips, where she says decades of research by organizational sciences and economists show that socially diverse groups, that's identity diversity, are more innovative than identity homogeneous groups. Then she says, it seems obvious what I just got done telling you for the last 35 minutes, right? She says, what Scott just told you seems fairly obvious. If people think about the world differently, they should be good. It's less obvious that social diversity should do the same thing. Yet if you look kind of across all these studies, it does, right? The best groups are also kind of identity diverse. And Richard Friedman has looked at, it's a smaller sample, it's only 16 million papers. It wipes out all the social science papers. And if you just look at sort of ethnic diversity as a variable based on last name, there's a bonus from identity diversity in terms of ethnicity, okay? So again, it's kind of true. So how? How does it work? So first way it works is just the syllogism, right? Identity diversity correlates with cognitive diversity, therefore, right? So here's sort of the simple map. Identity diversity somehow must affect cognitive diversity, which must go to better outcomes. But to unpack that a little bit, right? You want to think of a person as having all these characteristics, a gender, a race, an age, a sexual orientation, ethnicity, a social class, coming from some neighborhood, some sort of religion. And then, so that's identity on the left, and the information we have, the knowledge we have, the heuristics and tools we've learned, the way we represent things, the models we carry around in our heads, the tools, the schema, all that stuff, that's all the cognitive stuff, right? The question is, and this is an interesting empirical question, how did all the stuff on the left map to all the stuff on the right? You can't prove anything there scientifically, right? I can't prove if I have different representations. I can't write some sort of diversity prediction theorem for identity mapping into these different ways of thinking. What you can ask is empirically, how does that stuff play out, right? To what extent do these things affect the other things? And there's been a huge shift in the last decade, and that huge shift sometimes gets turned under the phrase intersectionality, sometimes it's under the phrase non-decomposability, but it used to be we would look at these things like this and say, what is the effect of gender? What is the effect of race? What is the effect of age? And we tried to pluck out each of those dimensions. Now that's seen as not working very well, and the reason why is each one of us is a bundle, right? And so you can't pull these things out. So Catherine, and incidentally, just as an aside, Princeton just had me in, and I was talking to their president and all of their deans, and the president said, if diversity is so good, how come you just wrote a book on diversity by yourself? And I'm like, that's a good point. I didn't, and if you buy the book, you'll see that Catherine actually, the way we decided to do the book is I wrote the main part of the book, and then Catherine wrote a critique of the book in the book. And I wasn't allowed to read the critique until the book came out. So as far as I know, Darryl Strawberry and I are the only people that have written books where we hadn't read them before they're actually published. Okay, so there's a famous quote by Darryl Strawberry who's waiting for his autobiography to come out so he could read it, right? The same was true for me in this book. So we had Catherine in to give a distinguished faculty lecture at the University of Michigan a couple years ago, and someone said, I don't understand this idea about non-decomposability. And she goes, well, let me give my answer. So she gave an answer, and then she turned to me because I was sitting in the crowd, and she said, Scott, give your answer. She goes, here's the point. Now that you heard my answer, and you've heard Scott's answer, you still don't know what a black guy thinks, right? You can't pull out her African-American component, my male component, and combine them, right? An African-American male is different than an African-American woman plus a white male, right? And so the idea is that you can't, a lot of the old regression studies looking at sort of is there effect of this one variable have huge variance terms. And the reason why is because there's so many other dimensions interacting with those things, okay? Second effect, and this one may be larger than the first one, and if you buy the book, this is what Catherine talks about in length. People tend to think differently and harder when around identity diverse people. So this is a really interesting study where it's fairly easy to create bubbles. Economists have found it really easy to create bubbles in laboratory experiments with markets. And then Sheen Levine, who's at Texas, and some other people said, I wonder if that's because most of these experiments are done with homogeneous groups of people. So they reran the same experience with non-homogeneous groups of people, and what they found is it's much harder to get bubbles with non-homogeneous groups of people. Because if I'm in a room with people who don't look like me and the market seems to be getting a little bit too high, I'm like, yeah, no way. These people must be crazy, right? But if I'm in a group of people who all look like me and the prices are way high, I'm like, oh, it must be high because these people are all really smart because they look like me. So Sheen has this wonderful quote that he calls the Siren call of sameness, right? That we really are persuaded by and trust people who look like us. And we're sometimes skeptical of people who don't look like us. So what Catherine talks about and what Sheen talks about, which is fascinating, is that sometimes inherent lack of trust or that extra barrier we have to go through with people who come from different identity groups actually helps us in the group setting. Okay? Third thing, agenda effects. Identity diversity influences what we study. And there's overwhelming research on this. This is my favorite from economics. This is Ma and Pa Ingalls. Until they let women in the economics profession, nothing Ma Ingalls did counted. Nothing. The reason why is it was all home production, so none of it got priced. Like all the chicken pot pies she made, all the, the home garden, none of that was priced, none of that was sold in market. Everything Pa Ingalls did was sold in market, so nothing she did got counted. And that was true when they sort of calculated world GDPs per capita across countries. Nothing women did, nothing that wasn't in the market counted. Then, some crazy idea in the 1970s when they let women become economists, they said, hey, guess what, guys? Women are working as well, right? It's just not being priced, and it changed how we do things. Google, when you go to Google, there's a little thing like, it's Einstein's birthday, like above the little search engine. Even though Marissa Mayer, who's a woman, was running it, this is a chart that goes the wrong way for some reason, but from 2001 to 2007, never was there a woman on that thing. Then they said, maybe we should have some women, and so they got to 16% because they got a memo saying there should be some women, but then they just couldn't get it. And so finally in 2014, they just said, okay, from now on, since the culture here is so warped, we're just going to have a rule that it's got to be half women. Because last time we checked, half the population was women, right? So again, you see, without having enough women in the company, you don't get these going the right way. For research, this plays out a lot. This is Rosario Cabello, who's a head of our Women's Studies Department in Michigan. She studies infertility among African-American women. Until she studied infertility among African-American women, nobody studied infertility among African-American women. There were hundreds and hundreds of papers about infertility among wealthy white women, but none about poor African-American women. So there's the phrase kind of nothing about us without us, which is often put in political terms, like don't pass laws about us unless we're included. The opposite happens in the academy. There's no research about people, right? There's nothing about groups of people unless they're in the academy. Fourth argument, and this is the most subtle, as you make a place more inclusive, you not only get more talent, so this is a standard story, right? Increase the size of the pool, increase the size of the pool. If you make the pool larger, yes, you get more talent, but you also get more diversity. So there's a fabulous new book out by Jeffrey West, who is president of the Santa Fe Institute, called Scale. And if you do things like this is true of like ecosystems, as you make an ecosystem larger, this is a log-log plot, you get more species. Well, the same is true for people. If you make a city larger, you get more industries. If you make a city larger, you get more diverse internet searches, right? This is, if you make a university campus larger, this is the log of the student population, you get more student groups. So as you enlarge the set of people who are coming into your profession, not only do you get more talent, even if you weren't drawing from different populations, which you are, you would also get more diversity. So with scale comes more people at the top, you also get more difference. And since success depends on talent plus difference, you get better at what you do. Okay, so what do we do really quickly, like in the last 4 minutes? So the first thing, and probably the most important thing, even though I'm trained as a mathematician, so when I got into this space like a decade ago, this wasn't my goal. My goal was not to come out and give these talks. My goal was not to go visit all sorts of corporations. And I would go visit, I remember visiting the Department of Interior, and the person introducing me talked about them being on a diversity journey. And I started breaking out in hives. I'm like, oh my gosh, I'm in a place where people are talking about a diversity journey, right? But then I realized that there's actually a lot of truth to that. Each person in their own mind has some sense of kind of why it's important to be inclusive. And I think what's intriguing is every different organization I go to, every profession I meet, they're sort of in a different place. And the way I like to describe this is with David Foster Wallace's famous quote, where there's two goldfish swimming, and a third goldfish comes up and says, morning boys, how's the water? They kind of look at each other confused. He swims off, and then the one says, what the hell is water? Right? This is true in so many organizations. People don't have an understanding of even like what the culture is, right? And so one of the most important things to do is actually just somehow check the water, right? So this is Kim Scott, who was at Google, who has this wonderful notion that she calls sort of radical candor. So she says, here's one way of sort of boxing what a culture is like. There's many, but I'm just putting up one. You can ask, do people care about people personally, and do they challenge them directly? If you challenge people but don't care about them, you're in this obnoxious aggression box. The place where I work, the University of Michigan, actually has the opposite problem. We're in the ruinous empathy box, right? We work so hard to be inclusive that sometimes we don't challenge people directly, right? We're just so happy to have people from lots of different places. But where you want to be is in this radical candor box. So in one of my departments, we actually changed the name of the graduate student seminar to the Graduate Student Radical Candor Seminar, just to sort of let them know, look, the reason we're being mean to you is because we care about you. Right? You're not going to get any better unless we challenge you directly. Okay? So this means, how do you check the water? You measure, right? So you do basic stuff like, are you promoting people? Are you paying people? Are you giving awards? Are committee assignments? Are hiring? Are performance? All these ratings, are they free of bias, right? So this is why hospitals, nonprofits, for-profits, government, everybody's doing this sort of bias training, right, on measurement, because we want to make sure just the basic blocking and tackling measurement, you're getting the right way. You also want to look at impact. So let's go back to this prediction thing, this accuracy of predictions. In this liver transplant decision, there's really two decisions. One is, which patients do you take? And the other is, how do you care for those patients? Well, it could be, when you're looking at which patients do you take, that actually the social worker and the financial analyst aren't giving good information. I mean, it may be that like if you actually look at the data and ask, are they good at predicting who's having a successful operation? Maybe they work, maybe they don't work. Quick aside, right? I was visiting one of the world's largest pharmaceutical companies, and they make these decisions about whether they take a molecule to testing, and then if the molecule goes to testing, they take it to market. Each one of those is made by, each one of those decisions, which in the first stage is like a $20 million decision, and the second stage is like a $400 million decision, right, is made by a committee. I said to the chief scientific officer, who's good? He said, what do you mean? I said, well, who's good at making those predictions? What are people's track records? He said, we just started keeping track of that data. I said, when? He goes, when you ask me that question. This is a $400 million decision, and they're not keeping data, right? Major League Baseball keeps data on every single pitch, right? If you're making hundreds of decisions about who's getting transplants, you should use the data, and you should see, is it worthwhile having the nutritionist in these meetings, or is it not worthwhile? Because it's costly to be diverse, and it also can be beneficial. And remember that Google graph, right? There's going to be some sweet spot, and this is where you got to sort of combine the understanding that diversity helps with the fact that you can gather data. But when you look at care, it could be that the surgeons matter less and the transplant team coordinator may not matter at all, right? But the nutritionist and the pharmacist may matter a lot. So what you want to do is you want to sort of cast a wide net, gather data, and then figure out what's going to work. The most important thing in this checking the water is the beliefs thing. So this is one of my sort of favorite stories, that this is a meritocracy. So I met with this is Volkswagen's leadership team. Volkswagen, the ones, remember the cheating on the emission standard team, right? So I met with the leadership of a team, of a corporation roughly this size, and I walked in the room and they looked pretty much like this. It was a different nationality, but they're all men, all from the same ethnic group. And I said to the CEO, I said, tell me about your culture. And he said, this is a meritocracy. And I grew up a hillbilly in rural Michigan, so I'm a really bad poker player. Like I don't have that, I was not trained to sort of like hide my emotions, and I just looked like I got hit by a truck. And he's like, you don't seem to believe me. And I said, I don't believe you. I'm looking at 9 German guys, and you've got 147,000 employees from 65 countries, and I'm looking at 9 German guys. And he said, our Indian woman is sick. Which was true. It was true, so just got up some slack, right? The Indian woman was sick. And so, but look, you don't get to be CEO of a major corporation without being really, really smart. So this guy goes, let's check this. So we sent out a survey to 6,000 people. From him, 5,983 responded within 2 hours, because it was from the CEO. And it had on there a question, which was, are we a meritocracy? The dominant male ethnic group strongly agreed with that statement at a rate of 95%, and fewer than half of women did. That's checking the water, right? So it turns out they were a meritocracy for the people in the room. Okay. Next quick thing. So a few years ago, I got to Atul Gawande, got tenure. They asked me to write Gawande a tenure letter at Harvard, and I'm like, he and I say the opposite thing. Like, I know, that's why we're asking you to get tenure. I'm like, are you trying to sink him? Like, no, we always want the critic to see what he says. But a friend of mine who works at Michigan's emergency room jokes about the Page Triage, which when somebody comes in the emergency room, they basically say, is this a checklist item, right? Did somebody just sprain their ankle, or is this really a complicated problem? And so one of the things we do is, so again, I'm not an all diversity all the time kind of guy, right? If it's easy, go full Gawande, apply the checklist. It's the Cheesecake Factory, right? If it's complicated, right, if it's hard, that's when you want to use diversity. And then the way you use diversity is to apply many models. So the book I'm finishing now, this diversity bonus book, the Mellon Foundation asked me to write. So this was the book I was writing that I stopped, that hopefully is coming out next spring. It's called The Model Thinker, and it's based on this online model thinking course that I teach. But the idea is we need to go at the world with lots of different models. So if you look at the opioid crisis, right, there's tons and tons of linear studies showing that, hey, this really, really worked. There's also sort of dynamical systems models showing that you can get this cycle of addiction. The models that they didn't construct were sort of systems dynamics models where they thought about the 40 million chronic pain sufferers, which were this giant untapped demand function for these opioids, right? So whenever you go back and sort of 360 an error, David Brooks had a wonderful piece in the New York Times a couple days ago talking about like he's from a set of people who thinks when we make mistakes it was because of errors. Usually when you go back and chase out the errors, it's because you didn't have the right model on the table. So one of the reasons why we want diverse people in the room is because they bring different models. I'm just going to end with this. This friend of mine, Victor Garcia, who's at Cincinnati Children's. I don't know if anybody knows Victor, but Victor is a pediatric heart surgeon. And so he comes home every day saying, just like puts a mark on the fireplace, saved another kid's life, saved another kid's life, saved another kid's life. Pretty good gig, right? One day he comes home and he says, I'm at the end of the supply chain. He'd seen a model on supply chains from businesses. And he goes, if I apply that model to what I'm doing, I'm fixing things after they've already broken. What car companies do is repair the process so we don't have to fix it. So now what he does is anytime when he's sending a patient home from heart surgery who's had a gunshot wound, he goes home with the patient. Because he wants to know what's the beginning of that supply chain that gave me the end of that supply chain. Right? So he's trying to, in some sense, get rid of his own job by solving it. All right. Thank you very, very much.